How to analyze experimental data. Have you ever wondered how to make sense of all the numbers and observations from your experiments? Analyzing experimental data is a key step in turning raw information into meaningful conclusions. Let's break it down into manageable steps, especially for those who learn best through hands-on experiences. First, organize and clean your data. Start by arranging your collected information in tables or spreadsheets. This helps you spot any errors, missing values, or outliers that could affect your results. A clean dataset is essential for accurate analysis. Next, move on to descriptive analysis. Summarize your data using basic statistics like mean, median, mode, range, and standard deviation. These measures give you a snapshot of your data's central tendency and variability, helping you see general trends. After that, conduct exploratory data analysis. This step involves visually and statistically examining your data to identify patterns or unusual points. Use tools like scatter plots, histograms, and box plots to reveal correlations or clusters that guide your next steps. Now, formulate your hypotheses. Based on your experimental design, state a clear hypothesis predicting how your independent variable affects the dependent variable. This hypothesis will be tested using statistical methods. Then, apply inferential statistics and hypothesis testing. Use these methods to draw conclusions about a larger population based on your sample data. Common tests include t-tests, analysis of variance, and regression analysis. These tests help determine if your observed differences are statistically significant or just due to chance. If you are studying relationships between variables, regression analysis is your next step. This method estimates how changes in one or more independent variables predict changes in a dependent variable. You can choose simple linear regression or more complex models depending on your experiment. Don't forget to check for errors and ensure statistical power. Understand the risks of type I errors, which are false positives, and type Roman II errors, which are false negatives. Make sure your sample size and test choices provide enough power to detect real effects. Once you have your results, interpret them carefully. Evaluate whether your data supports or refutes your hypothesis. Consider the size and direction of effects, confidence intervals, and practical significance, not just statistical significance. Finally, report your findings clearly. Use graphs, tables, and concise explanations to present your analysis. Being transparent about your methods and limitations strengthens the credibility of your conclusions. For those who learn best through doing, try applying these steps with hands-on activities. Physically sorting data cards, drawing graphs by hand, or using interactive software can make the process more engaging and memorable. By actively manipulating and visualizing data, you can better understand the analysis process. In summary, analyzing experimental data is about transforming raw numbers into evidence-based conclusions through systematic organization, visualization, statistical testing, and thoughtful interpretation. This approach helps ensure your study findings are reliable and meaningful.